Ora, boa noite ou boa tarde a todos. Okay, I'm gonna do it in English probably, no? Well, I'll do it, English is fine, right? I'll do it in English just in case. So, my name is João Carreiro. I've been what they call nowadays an entrepreneur all my life. I opened my first company when I was 18 years old, basically just to sell, basically to have a discount on computer parts because I spend a lot of money to have a nice PC because I played a lot of video games, was national champion for a video game back 15 years ago. And that grew to making computers for friends and family. It made me drop out of university because money was nicer than studying. And then it evolved and passed different phases like electronic security, home automation, and eventually it ended up in criminal investigation. That's what I did in my couple of last few years. So what exactly do I mean by criminal investigation? I actually really mean not the CSI kind of criminal investigation after the crimes happen, but the surveillance part. So basically, I still own a company that is a big supplier in Portugal of criminal investigation equipment, like very tiny cameras, GPSs to put under cars, stuff you see in movies. And that led me in 2011 to not only want to import stuff, but to actually develop our own products. And since 2011, until August last year, we developed a couple of products. Our flagship one was basically a tiny black box. You just connected a camera, connected a microphone if you wanted, battery, put a SIM card into it, send a text message to it, it will return an IP, and after that you could configure all the security features you wanted. VPN, VPN encryption, it had AES encryption 256, whatever. And it was very easy to use. In this market it was like pretty interesting for everybody because everything in this market looks very ugly, like, banking sector, kind of ugly. And we had the only product in the market that actually didn't need a manual and everybody could use. But moving on. So Mark Anderson, I don't know if you guys know Mark Anderson, but he's very well known. He basically invests mostly in media. So like he invested in, GitHub, Business Insider, Facebook, Twitter, Foursquare, and he also invested a little bit in hardware. Nowadays in 3D printing and drones, but he also invested in Jawbone, for example. I don't know if you heard of it, and Oculus, for example. But is it? So I don't think so. I think what is actually hard is hardware products. And there's a big difference. It's small in concept, but it's a big difference. Why? Because hardware is very easy nowadays. You have a ton of platforms. You have Raspberries, Arduinos, Bitoinos, and a ton of other things. You have code everywhere. You can basically do a big part of your prototype, even sometimes the entire prototype, just copying and pasting codes around the internet and changing very little things. So hardware is actually easy nowadays. What is hard is making it an actual product. When you go from there and want to sell it to millions of people, hopefully. So, and why is that? Basically, let's start with main difference is when you're doing a software product, you can get to the prototype with just a programmer. Like someone alone can do that. Maybe sometimes in a weekend. With hardware, it's very hard, especially when you're moving from the proof of concept to the prototype. It's very hard for you to not have a team with an electronic guy, a mechanical guy, an industrial designer. UX is not in the circle because it's something that I think, it depends. You don't really need a dedicated guy for UX, especially if you have a really small team, but it's core that you focus a lot of your development effort in making it very easy to use. But that's just the beginning of your journey, right? So apart from that and comparing it to a software product, you have a lot more. Especially on this side, you need to deal with regulations, you need to deal with certifications, the finances are a lot harder because you have all the logistics parts. So supply chain, manufacturing, and even the business development it's harder. If you're selling online, that's fine, but it's very hard for a hardware product. If you want to go retail, then it's like a whole world of complex. So let's start. And just a last tidbit before we start. You probably hear this a lot. I'm guessing most of you are in software somewhere related to software development, because that's most of the crowd here. And a lot of people say that good enough is perfect. And I strongly think this is something that I use a lot, and that sometimes when I need to make decisions in my life, I go back and think, is it good enough to launch? Should I add something more? Should we keep making it better and getting rid of bugs? So I think this is still true if you're developing a hardware product. But you need to be very careful, because the concept of MVP in hardware, you basically need to get it right, or a lot closer to right than in a software product. And why? Because it's a very big trap. Not because you can't change anything. A lot of things on a hardware product you can actually change along the way. Like if the product actually works and it's just something like changing a few pieces on the board, I mean, that doesn't have that much impact, depending on the stock you got in the first place, but it's not that serious. Code, you can upload the code over the air. I hope if you're doing an electronic consumer product nowadays, especially, you make it so you can update the software over the air. But it's a problem. Why? It can induce you in a very big mistake. You launch the product and it starts picking up a lot. Maybe because you got right the problem space, and you're actually solving something that people want. You're doing something that people want. But if you don't get right all the rest, the UX especially, you're gonna end up right there in the chasm. So this is the normal life cycle, traditional life cycle in textbooks for any product. If your product has a normal cycle, and you're gonna fall there, and you're not gonna be able to recover from that. So you need to pay attention to that. But this being said, let's get into the actual steps. Someone is dying over there. The first 5 are a little more boring, more connected maybe to management and planning. The last 5 are more technical. But remember, this is just a very top approach for a general introduction, so we don't actually go into a lot of detail into anything. Just looking at the time here, it's fine. So first of all, obviously keep it simple. Keep it as simple as possible. This is true for software, it's true for hardware. Aim to have no manual required. Like, I don't want to buy a 900, 1,000 euros kitchen robot like a Bimby, and then having to open a manual to work with it the first time. Focus on the magic moment. So the magic moment, for me personally, I identify 2 magic moments when I'm developing a new product. One of them is when the user acquires the product, the customer, and when they open the box. So it's basically the time from when he starts opening the box to the first time he smiles. Apple, for example, gets this very well. So normally everybody that you see opening the box of a new iPhone smiles as soon as they actually see the phone. So this is perfect. This is probably as soon as you can get. The second smile is the first smile the person gets when they're actually using the product. So a lot of companies go into a lot of effort to get that right and test this a lot. Make a ton of people open their product and actually try to measure their reaction and identify the first positive reaction they have. Because as soon as you have a positive reaction, even if your first experience with the phone, like you turn on the iPhone, it's a little bit slow booting up or something because it's doing updates, who cares? You're gonna have a more positive approach to it. Like, oh, it's so nice, you're already smiling, so you're more resilient to tolerate a few mistakes from the product. And the last advice I can give you about this, it's like really, like the founder of Pat says, try to hit the defaults. If you're doing a product that needs a lot of different configurations, like a car, for example, nowadays has a ton of configurations that you can turn on and off. Like, I don't know, automatic lights, the volume of the radio when you turn on the car when you first receive it. Is it the radio on, is it not? You could display a welcoming message when the person actually buys the car and enters the first time. All this can be thought out and normally isn't. So this is something that you should really think about. Second thing, so you're starting to develop your product, and I strongly advise you to set up some kind of product requirements. It might just be in the terms of goals or specifications. These are all different things, but it's really important. Probably a lot of you already saw this. It's not that this actually literally happens like this, but it happens a lot that people aren't developing exactly what you want them to develop. And this happens because if you don't have it in writing and very clear, people are going to understand it differently. So if you just want to make an electric car that does 300 kilometers of autonomy, a guy might come up with a Tesla, a guy might come up with a Prius. So it still does 300 kilometers, it's still an electric car, so it's important for you to try to really focus the most important thing. Or else, even the best possible scenario is that every once a month, one of your part of your development team just spent 3-4 days actually developing a feature that isn't supposed to be on the first release, for example. So this is important. But in the beginning, especially if you're doing it in a startup environment, just make it like one page. One page is more than enough. Like, what is your core objective? What is the core feeling that you want your customer to have from your product? For example, when you're developing a Tesla, you want a comfortable car, a cool car, a good-looking car. It has a ton of specifications that need to be followed. And really don't try to make it too big. In the beginning, you can start with just the feelings you want the person to have when using your product, and then move on to the actual specifications. Basically, just focus in what really makes your product different. Like, if it doesn't make your product different, you probably don't want to care that much in the early releases. The other reason to work on specifications, at least along the way, is because you're going to need them anyway. Like, this is a manufacturing line, and somewhere here, there are going to be people doing quality assurance. Those people need to know what they're actually testing the product for. If you don't write anything from the early development cycle, you're going to end up having the product finished and then writing what the people are going to test it. And doing this from scratch believe me, takes a long time, and it's pointless. It's just a waste of time. So, I guess again, some of you heard about the Lean startup methodology. If you haven't, it's very easy. It's just based on building, measuring, and learning from what you just built and what you just measured. Some people say this isn't doable in hardware development. I disagree, and I think most people nowadays tend to disagree. Even big corporates are moving along those ways. What I advise you to do is to really first have the engineering and design team working from the first moment in parallel. Like the old school hardware product development would be based in first having the engineers going all the way to a reasonably good prototype, and then involving the designers to design around the product. Like, just involve them from the really beginning. And it's basically this. The feedback can come from your team before it comes from the outside. It can come from friends and family. And then you can actually move to early customers, a beta release, whatever. And the steps here are supposed to be really small. I'm going to use the example of Pebble here because they are nice to have a lot of materials online. So as you can see, they first started gathering feedback on drawings, then 3D renders, and then at the same time, software running on an iPhone strapped to your wrist. But at the same time they're doing this to test the menus and the navigation, they're also testing 3D printed versions of the enclosure, and then moving on to CNC made parts and to the finished product. So really break it down into small steps, and you should really try to have something different to test like almost every week. On the hardware side, same thing. So this is, as you can see, they started testing some of the features in the Nokia 3310. So you can start testing stuff very early from anything. In the beginning, people normally start with the card box. You just pick up pieces of card and try to make a rendering of the size of it. Like if you're doing a kitchen robot, for example, you can use cardboard to imagine the actual size of it and the food that sits inside, and then pick up the cardboard, paint it, and put it on the kitchen and look, yeah, is this what we're aiming to do? Is this along the lines we want it to become? So really try to make small iterations. The last boring point here, branding. This is really not my area, but it's really important. Nowadays, all the most successful products are heavily based on identity. This happens with a lot of known brands. Pebble, iPhone, Tesla, all of them have this OnePlus. Some of you might know OnePlus phone manufacturing. So OnePlus rose in sales really fast, and they had a partnership with a big manufacturer, but they were a small team, and they actually launched a new from the ground up with a very small team. In the beginning, they were less than 10 people for quite a few months. So your identity is really important. Why is also your identity really important? Because when you're making your product, you're imagining that when you finally get to a retail space, I'm obviously focusing more in consumer products here, you're gonna have something like this. Your big name there, 4 or 3 of your different products in different colors standing by, all looking very great. The reality is this: the first time you get into retail, it's very likely that you're going to be that small orange box on that bottom shelf there. You probably can see it, and that's because most consumers won't see it either. So it's really hard to get in retail, it's really hard to get space, and if you're a new product with no traction, even if you can get in, like with the help of an accelerator maybe, if you want to go from there to a shelf that people can actually see, you need to pay for that. That's called placement, and you need to pay for them. Even if it's, I'm not talking about a pop-up on the hallway like people normally do for yogurts. No, even to get out of the bottom shelf for sure, you need to pay for that normally. So it's kind of demanding. And basically your brand is just this. But really try to also incorporate in your brand your true identity. I know sometimes it sounds like bullshit, but making a startup is really hard, believe me. And it's important that you have something to grab yourself onto in the tough moments and really and the moments of indecision, and you can go back and find out what actually is more important to us. Is it speed? Is it autonomy? What are we aiming for here? So as you can see, until now you're probably imagining, making a hardware product costs a ton of money. And I mean, you can do it with let's say it's feasible to do it with startups, it's just really hard. But let's actually get to the numbers parts and some more technical parts that I think you're probably gonna enjoy more now. So if any of you by any chance started kind of working with hardware, you probably, the first thing you come across when you're trying to find out the price and how much your product is going to cost is the BOM. The BOM is the bill of materials. And it's basically a list of everything that you're getting into your product. It's a very simple concept, right? But in reality, it matters very, very little. So, and this is one of the first terrible mistakes of startups in the hardware space. The important thing here is COGS. COGS is the cost of goods sold. And COGS incorporate a ton of stuff. First of all, it includes the BOM. And the BOM, if you're making it anyway, try to make it, this is an example from Bunny, a guy some of you might know. Try to make it as complete as possible, identifying the amounts of packaging you're gonna buy each component into. Maybe you need 1,000 resistors, but you just need 100 lenses. I don't know. Also identify the lead time. This is really important because lead times vary a lot depending on components, and this can really screw you up if you're working on your product for like 2 years and then you're like, yeah, we're ready for manufacturing, let's just start ordering and we're going to start producing next month, and then you have components that take 2 months to arrive and your product is already finished, so you're just going to sit there for 2 months, and this happens, believe it. And then if you look at the 2 bottom rows, That's another of a very common mistake. Not including in your BOM the card boxes, like the packaging of your product. And if you're going for something like this, it's very significant. This can be like a 10 euro package, even if you're building like 1 million units. Colored cardboard, foam to hold the headphones into place, adding the manuals to it, all the things to hold the cables, nice ties for the cables, not those shitty Chinese things with barbed wire. That all adds up. But basically think that your product needs to come, this is already your initial packaging, then you need a box to put them into, then you need a bigger box to put them in a pallet, and maybe depending on the fragility of your product, you're going to need a big part of card to put around the boxes in the pallet to make sure it arrives at the destination safely. And each of these boxes normally also has foam and all the stuff to keep the things in places and all that. But moving on, just to close the COGS part, the COGS includes all this. So this is actually your cost of manufacturing a product. You need to add to the BOM the assembly labor. So, I mean, even if you're building the product in Asia, it's cheap, but it's not free. So most of your products, if you're building a product, they're assembled by hand. A lot of people get shocked when they imagine that phones are assembled mostly by hand, but they are. Unless you're a very big manufacturer and you're doing like millions of units, or you have a very specific product, like for example, Tesla started from the beginning wanting to have the most optimized factory in the world. But those are very specific cases. In general, your product is going to be assembled by hand. So that takes time. If you're doing it in Asia, which is very common nowadays, unfortunately, because we can actually build pretty much anything we want with Portuguese companies, Asia normally has a very streamlined process of working. Most factories actually charge you for the normal component price at sometimes cheaper than yourself would gonna buy it, and then they just add their margin on top of it. It's a very transparent way of working. And I like it. It's very transparent, and I like transparent ways of working. Scrap rate, you're building a new product, maybe your industrial designer made a mistake somewhere, you're going to have a lot of products coming out of your line and going to the garbage. This happens even with big companies. It happens with any product, and normally, if in the beginning you have a scrap rate below 10%, that's actually good for your first product. The freight, so the product needs to go from the factory to just checking the time, to the harbor, for example, then to a warehouse in Europe, in the US, then from that warehouse to the warehouse of Sonai or Media Market or wherever. So there's a lot of logistic costs here. 3PL are third-party logistics. So this is in the case that you hire a company to take care of all this for you. It's very common, the easiest way. It's probably the safest path to go, and I strongly advise it. And returns. Like, especially if you're going to put your product in retail, that's very hard. You might, if you shop at Media Market, for example, Media Market has a policy of accepting anything back for no questions asked. This is very nice, but what Media Market does next, it is put the product in its packaging or a shitty box they have around, send it back to the manufacturer for the manufacturer to test it again and repackage it. So you're paying for all this. You're paying for the shipping from Media Market to your company and repackaging and sending it back. So this starts to add up. Anyway, you're moving to mass manufacturing. So just a few concepts, basic concepts I think you should know about this. No, you have the design for manufacturing is obviously the most common and the one you can find anywhere if you search for making hardware products on the internet. And then there are different concepts, design for assembly, design for testing, design for cost. All this normally is done with help from your factory. So the factory you hire, they normally help you in making your product easier to assemble, less likely to have mistakes in assembly, like having less screws, having all the screws the same type. All this helps a lot in making sure you produce faster and cheaper. But still, when you're moving to mass manufacturing, then you have a ton of hidden costs, and these are called fixed costs. And this is the final, let's say, the final money-related thing I'm going to mention here. And it's all the costs you have to actually put your product into production. First of all, there's all the NRE. So that's non-recurring engineering. It's all the engineering work that needs to be done to start manufacturing your product. For example, setting up the manufacturing line. Even if you're doing a phone and the factory already does phones, sometimes you need to change stuff from place in the manufacturing line. You need to change tools on the manufacturing line. You need to change the speeds of some machines on the manufacturing line to fit your process of manufacturing the product, and all that costs money and is charged back to you. And then you start producing the product, and first you build a few dozen units to test the engineering, like to see if the product is coming out okay. This is mostly the electronic part, obviously. You do the same for the design. Like you just make a few enclosures, like a dozen of them or so, to check out if the molding tools are working all right, if everything fits together, if everything is fine. And then you move to the product validation. And here you actually want to make sure you build like a couple of 100 units. So this is a couple of 100 units that you most likely won't ever sell. And this obviously costs money again. If you don't do all this, it's going to cost you on the long run. So it's not steps that you can actually skip. And then you have the obvious, like injection molding tools, stamping tools, and the certification. We're kind of going to go into that later. This all is very complex, and it takes a ton of time, and time costs a ton of money. So normally you have the materials like resistors, buttons, lenses, batteries. They all go into a factory. That factory makes the PCBs. Another factory makes the plastic enclosures. Another factory makes your packaging, and then they all join together in the assembly line. And this is normally another factory. Well, not normally, but often it's still another factory. So things need to move ahead. This is why, for example, Auto Europa has a very big park of companies around it, so that the moving from place to place is just crossing the street. That saves obviously a ton of money and speed. And then they go to a warehouse, then they are shipped to the right continent, like to the US, for example, and then they go to a warehouse again, and then they're shipped again. And so, as you can see, it all takes a long time. Final step on this, the testing of your product. So if you're building a product, in this case, this is from an Audi, I don't remember an Audi A4, I think. So this is the test rig for an Audi A4 entertainment system. They obviously, in Audi, because they do millions, they don't test every single unit. But OnePlus, for example, tested every single phone for quite some time. So that means you need to write what you want the people that are working there to actually do with the product to make sure it works. Like, is it pressing buttons? You can automate a lot of this. If you go into IKEA, for example, they have on the hallways those machines to pretend they're sitting down on couches and chairs. So there's stuff you can automate, there's stuff you actually can't. And it's important that you don't automate everything, because different people will press the buttons in different angles, will treat the product in different ways. And for most, you can do all the testing you want, there's still going to be problems in your product as soon as it gets out in the world. So you finally have all your products. So what do you want to do now? You want to start selling. Just a little, this is very high level, just a little information to give you an idea. If you're selling direct, you basically just need to worry in fulfilling the orders. So someone makes an order, you need to have someone to put a sticker in a box, package it, put it in the mail, wait for UPS to show up, whatever. And the processing fee from the payment, if you're using PayPal, for example, or if you're using credit cards, you're going to lose a percentage there. But compared to the other options, it's very small. If you go online, you want to insert the insurance cost there. because if you don't insert the insurance cost, it's very likely that even if the product is damaged in like media market warehouse, you're gonna pay for it anyway. The margin here is like 15 to 30%. Obviously, if it's like some type of products have smaller margins, some have bigger. Like a television, for example, can reach 50%. So actually, a Fnac can earn 50% on a television they're selling you. If it's like a computer, a laptop, it can be below 15%. It can be like 10%. Depends on the market and the type of product. But if you're launching a new product, being it whatever, a smartwatch, drop cam, Nest, you're going to be close to the top. So they're going to ask close to 30. Physical retail, even harder. You might get away with 30, but the margins can go up to 50. 50 is normally like if you're selling on an Apple store, Apple asks like 40-50% of everything they sell in there that isn't from Apple. Sometimes it's worth it, sometimes it's not. Most startups just try to put products in Apple stores to say they have products in Apple stores. And this is actually cool. I mean, it's not, I wouldn't call it bullshit, it's needed. It's a good marketing strategy. But normally, people that go to Apple stores basically buy Apple stuff. So it's more something of free advertisement, that it's not actually free, but it's better than nothing. And then you might have to pay for the product placement, like I said before, and the loading cost. It's basically actually paying them from all the costs they have of managing your product in their warehouses. This is an example I did about a product that costs about $75 to manufacture. And see here that I included everything from the BOM, the COGS, the fixed costs, the product placement, the marketing, and the loading costs, like everything you should consider for the product. And if your product is costing $74, when you add all this up, that means you probably need to sell it for like $299. So it's pretty hard. As you can see, some of the costs, most of the costs go down linearly as you add up quantities and go down really fast. So that's 10,000 units, 25,000 units, 100,000 units, 1 million. Pricing strategy. Nowadays, okay, we have time. Nowadays, most hardware products are not based, at least the ones that come from new companies, are no longer based in just actually selling the product. If you need investment, investors don't like that. They want business models that are based in something else. For example, it can be selling consumables like Delta or Gillette, for example, or inkjet printers. It can be based on the community and ecosystem. This is more the OnePlus approach, for example. They worked very strongly in having a strong community. If you go to the forum online of OnePlus, it's ridiculous. Everybody posts there. They just created their own social network around their product and worked very well for them. It might be based on data. For example, Amazon sells some products at cost, and some of them they even lose money selling them because they get it back with the data they get from customers and with the products they sell on top of it. And then you have all the laws, regulations, standards, certifications, guidance, marks. These may all seem the same. They're all different stuff. I'm just going to give you a few examples. So SAR, for example, is the absorption rate of radiation. So this is mandatory if you're using a GSM modem, an LTE modem, whatever. RF if you have anything that may cause radio interference. Environmental has two sides of it. One side is the consumption, for example, like to have an energy class, like if it's a home appliance or even cars and tires, for example, nowadays. But it also has the other side that if your product doesn't use forbidden materials, if it's easy to recycle, and it might be mandatory or optional. even if it's optional, it's nice for you to pay a little attention to it and make sure your product is easy to recycle and you don't contribute to the mess that's happening in some countries. And there's still another side for environmental certification. That's about the humidity your product works at. Humidity, temperatures, you normally always see that on product specifications. So that's that. You might have proprietary, for example, if you want to do a 3D headset that works with Google, now you have to have it Daydream certified. You need to comply with Google certification. Do you need to do that to have 3D goggles that work with basically anything in the market? No, but the consumers might start paying a lot of attention to it. So you might want to also pay attention to it. Some of them are more strict. For example, if you want to have Android App Store on your phone and Google Apps on your phone, you need to fulfill a lot of requirements from Google. An easy way to do this, if you're a startup, this is always a nightmare. And I don't know everything I need for every product. I don't know for products I even did in the past. This is ridiculous. It's like a mess. An easy way to start is look at the stickers on the products from your competitors or the closest you can find from your competitors and just see what's written there. And then use that as a starting point. Another good starting point are these two websites. In Europe, it's very easy to find a list of all the certification webs that certify any type of things. And it's actually very complete, and you select your type of product, then there are subcategories, and it's just going to tell you all the labs in Europe that can test your product. It doesn't tell you what you need to follow, but it tells you what labs test your product. Now, then you obviously reach the labs and say, okay, I have this. Can you make me a budget to test my product and to pass certification? Most of them are very old school and they won't tell you exactly what they're going to test your product for. So they are not going to give you a lot of details. They're going to be very broad so that you don't try to find labs that do it cheaper because you don't know what you're asking for. But I mean, some of them are becoming nicer and you can actually ask. You don't necessarily want to go with the cheaper lab you can find because good labs are going to help you fix your problems. If the lab is very good, they even give you advices before you pay them. Like if you sign the contract, sometimes they look at the product and they immediately say, look, this is going to fail. Like the modem is too close to something, just put a piece of aluminium here to make sure it passes the first time. So some of them are really nice, some aren't. This is basically the same from the US. It's not as easy, it's a lot more complicated, and the US has a lot more different organizations for different regulations, so it's more complex. For most of the stuff, there's not a lot you can do. Some of the stuff, it's very obvious, like if you're going to test your product for resistance, it's common sense, right? The requirements are very small. It's just it doesn't break into pieces that can kill people. So just like Samsung Note does, for example. So it's very common sense. I mean, drop it a few times, launch it against the wall. If it doesn't explode, it's fine. It's going to pass. It's not very hard. Radio interference is a totally different thing. It's very hard. It's very complex. With a couple of €1,000, you can buy equipment that is not going to give you accurate measures for even close, but it's going to give you a threshold. So you know if your equipment gives you X and you fail because your result was in the lab X plus 10, you then have a threshold and know that you need to reduce until a certain point. If you don't have any sort of way to measure anything, you're going to need to go to the lab in the dark and maybe fail again. So it helps a little bit, and you can do this with a couple of €1,000. Or find someone that has it. Last, patents. This is very easy because I don't want to go there. So I think patents are useless for startups. They even for big companies, they rarely make sense unless you're a really, really big corporate like IBM that can sign 1,000 patents a day. It's really pointless, and for two reasons. And the first one is because you're not going to be able to defend them. It's that easy. If Apple wants to do something that you have a patent for, you're not gonna, even if they're nice, I'm not saying they're gonna be evil for you, but if they just want to follow the normal path and take you to court and see where it goes, because they don't believe you're right, like both sides think you have the patent for that, Apple disagrees, you're gonna spend 4 years in there. A startup, you're not gonna last 4 years in there. You're gonna go bankrupt anyway. So it's pointless. And that was basically it. So thank you very much. I know at a certain point it was a lot of information, but well, I tried to cover everything I thought was important. Questions? Anyone?
To start. When is going No Bullshit Labs to open doors and start making awesome hardware with Portuguese hardware startups?
That's a good question. So No Bullshit Web is my new product. So I've been working in it for a year now, and it's going to be. And thank you for the question, Fernand. So I've been working on it for a year now, and hopefully it's still aimed at the same thing. So to launch in the end of January, but we're already late because we were supposed to announce it in the end of September, and we're in October, as you may have noticed. So the next target is to announce it in the end of October. Basically, it's the same thing as every startup. We're closing partnerships, we're trying to close investment. But for you to have an idea, it's going to be an accelerator with a makerspace with about 100,000, 150,000 euros of machinery from the beginning. With incubation space, we aim to have technicians from the beginning, like at least one guy from electronics, one guy from industrial design. And it's to help startups to develop products and get them to the market. So if you go to the website, there's a landing page there where you can put your email and then receive more information when we actually launch the website.
João, you said that you believe, you are convinced, and that's why you are creating No Bullshit Lab, that you can make in Portugal more or less the same thing that startups of hardware are doing on Shenzhen. So how is that possible? Because Shenzhen is so much more developed. They have a 30 million city and factories.
Well, what I meant is that we have the capability to do them here, and if we want, and if you're doing, for example, a product with very big margins, it's actually interesting to do it here. And you can do everything here, so you can do any kind of product in Portugal. We have the capabilities. Obviously, if you're aiming for the mass market, I would do it in Shenzhen. So it's not, I'm not gonna say do it in Portugal. It's still hard. You need to spend a lot of time there. You need to go there like at least every month. I never did. I was never very involved in building actually a consumer product. So I'm giving that. I'm talking based on my experience on doing more specific products. But yeah, I would do it if it's aimed at big quantities, like even more than 10,000 units. I would do it in Shenzhen.
Could make sense to the startup start here, and if it's scaled up, to go to Shenzhen?
Yeah, well, I think it makes sense to have the development here and go to the, not even prototype, but to the actual, to being very close to mass production, and then do the mass production there. But I wouldn't think that, especially if you're already based in Portugal, I don't see a lot of value to moving the entire company to Shenzhen. You're just relocating a lot of people. Most people there don't speak English. It's gonna make everything a nightmare. Like even going to a restaurant, it's tough. So I wouldn't add that. And the quality of life in Portugal compared to in Shenzhen, like the pollution, the green areas you have here, it's just not comparable. So it's very hard to build a startup. I would do it here.
Can I ask a question to the audience?
Sure.
anyone interested in build something, some hardware in the next year to come?
I'm from a company from Braga that already sells hardware product. As you say, we are made our hardware in Shenzhen, but our there is made here. Yeah. The company calls Quidbox, and the product is TV.
It's a TV?
TV.
Okay, that's interesting. Have you heard of it? That's cool.
I would like to know more about that.
That's nice. There's
It's a launching product. What's good? Your product is cool with a cube.
okay.
Well, it focuses on monitoring temperature in cold chain systems, but we're actually not still mass production. So we're just launching our, let's call it our first version / MVP. And it's actually, I'd like to talk to you a little later because a lot of stuff that you mentioned, some of the problems you're saying, we're either passing through them or made those mistakes. So it's kind of interesting.
I have a more relaxed, funny talk I did at Productize last year. It's on my LinkedIn. It's just 10 minutes. More based on my previous experience at Nozomi, my startup, and what we did to launch the product. We had, I can just give you a quick glimpse. We had a very niche product, obviously, in our market. So our product, even building like 5-10 units at a time, our product cost us like 500 euros, and we sold it like for 5,000. That was the beginning level, and then we had a few extras that basically added like 30 euros and added 1,000 euros on the price. So in this specific scenario, we actually did everything. I mean, we were selling the product with 3D printed enclosures. So we 3D printed the enclosure, we obviously gave it some treatment, we painted over it, we bought O-rings in Portugal, and we found in Portugal everything we needed. So we basically were the assembly line in our office. So from O-rings, from painting, from 3D printing the boxes, we did everything. And we were able to do it. So if you have a nice margin, like if you're not doing a consumer product, you can do it. In a consumer product, it's harder.
Yeah.
Was there something you thought that, I don't know, what did you think was most interesting of the 10 points? Like, I guess more the last 5 because they're a little more technical, but there's a lot of information. Was something that you didn't know was like that? I don't know. For example, a lot of people assume that all the products nowadays are assembled by robots and all the screws are screwed by robots. Did you thought that in general?
Just the 4.0 is bigger to get.
Actually, from our experience, we already had that. Yeah, I passed the mic to Make it speak louder. Yeah. I was just saying that from our experience, some of this, at least for me, the funniest, I'd say most interesting things were the fact that a lot of things that you were saying we're either passing through them or already figured them. So even those non-robotic assembly, I mean.
Yeah, I might have.
That's our experience, of course.
Because this is an intro and I actually didn't have a lot of time to prepare. I mean, I might have said some stuff that might be misinterpreted, like the thing of manufacturing everything in Portugal. Sometimes that happens. So, but in January, I think, try to cover everything. Well, that's cool. I'll be around until Saturday. I'll probably leave very late in the night today, or not leave at all. So, feel free to talk to me when you want. Okay. Thank you, and thank you for coming.